So imagine securing your entire code base with just a single slash command.
Right before your CI/CD pipeline even boots up.
Exactly. So today, our mission for this deep dive is, well, exploring this workflow that promises like 80% of your repository security results with just 20% of the effort.
It's a really fascinating concept. We're looking at a DEV community article by Alexander Titan, and there's a companion YouTube demo from Open Mentor app.
Yeah, they call it an AI-powered anti-gravity workflow, which sounds awesome.
It does. I mean, usually running a full suite of open source scanners, things like GitLeaks, SEMREP, Checkoff, OSV Scanner, it generates just a mountain of raw JSON.
Oh, tons of it.
Right, and feeding all of that directly into an LLM is just a fast track to maxing out your context window.
And driving up your API costs, right? It's like shoving a massive unindexed data dump at a detective.
Exactly, shoving an encyclopedia through a tiny mail slot.
Right. The AI doesn't need the whole abstract syntax tree or, a list of every single test that passed.
No, and that's where the author introduces this idea of the token economy. They basically use JQ to parse and minify those scanner outputs.
By like 90%, right?
Yeah, roughly 90%. You're keeping the prompt lean. You only send what broke, where it is, and why it matters.
Which lets you use a super fast, cheap model like Gemini 3 Flash.
Exactly. And then it synthesizes those concentrated findings into a strictly structured markdown report. You literally just type review security repo inside the IDE and get a sweep in minutes.
And the video demo for this is wild. The AI agent actually caught a proto-denial of service vulnerability.
Right, because traditional scanners mostly just look for known signatures.
Yeah, but the LLM looked at the flagged code blocks and, inferred that the logic itself could be exploited to overwhelm the system.
It gets better, though. The agent actually has a built-in feedback loop.
Wait, really? How does that work?
So in the demo, the workflow hit a syntax error while executing that JQ parsing command we talked about.
Oh, wow, okay.
And instead of just failing, the agent read the standard error output from the terminal, recognized its own syntax flaw, rewrote the prompt, and re-executed the command.
Seamlessly. That is honestly a little scary.
It's very cool. But, shrinking data by 90% isn't without risks.
Right, that's my big question. Aren't you creating a massive blind spot?
Yeah.
Like throwing the baby out with the bathwater just to save some tokens?
It's a valid concern. If you wipe the fingerprints off the murder weapon, the detective can't do their job.
Exactly. If I just send the AI a file name and a rule violation from GitLeaks, how does it know if it's a real leaked API key
Or just a harmless test fixture.
Right, like example key 123.
That is the exact tension of this token economy, and it actually came up in the comments.
Oh.
Yeah, a developer named ArcForge pointed out that the JQ minification step was dropping the match field.
Ah, and that field contains the actual string that triggered the alert, right?
Exactly. Stripping it out completely blindfolds the model to the actual evidence.
Because relying purely on file name heuristics just won't cut it.
Right, so you have to add those minimal tokens back, like the match field in GitLeaks, or the .extra.message field in SEMREP.
So it's this delicate balance between token efficiency and context retention.
Precisely. But there's also the broader architectural context to consider.
What do you mean?
Well, another developer, AgentWork, raised a good point. An automated agent catching isolated rule violations might miss deeper contextual threats.
Because it doesn't understand the whole repository.
Exactly. But the author has a solution for that too. They feed the AI specially optimized context docs that live directly inside the repo.
Oh, like a custom cheat sheet for the project's architecture.
Yeah, it gives the LLM that broader perspective it needs to evaluate those isolated flagged issues.
That is so smart. So if you're building out your own pipeline, I guess the main takeaway is that token curation is just as important as model selection.
Absolutely. You don't have to choose between speed and security if you tightly control the data your AI reads.
Right. But the system is still evolving, obviously.
Oh, for sure. The author actually poses a great puzzle for anyone looking to try this. What tools are missing from this one command security check?
Yeah, and how else can we optimize that token economy to bring false positives down to absolute zero?
It's definitely something to experiment with in your own projects.
Well, something to chew on as we wrap up today. We are looking at an AI agent that orchestrates traditional security tools, parses the JSON, synthesizes a report, and, like you said, fixes its own syntax mistakes on the fly.
It's incredibly autonomous.
It is. So if it possesses that level of operational autonomy today, how long until the agent is just writing the code, scanning the code, and approving the code entirely on its own?
That's the real question.
Will we even need to curate the data, or will the AI just be running the whole show? Something for you to think about until next time.